Hi everyone, this is Ravi Prakash and welcome to 7th class of geometry, right? So here we'll discuss about similarity of triangles, right? Similarity of triangles. So in similarity of triangles, right? How to prove two triangles are similar, what are its use, how to apply it, right? Everything we'll do, right? Similarity of triangles. See, how to prove two triangles are similar, right? There are three ways basically. First is SSS, second is AA similarity, and third is SAS similarity, right? There are three ways by which we can prove two triangles to be similar, right? Now, what is SSS similarity? So SSS similarity is basically in two triangles ratio of all the sides, all the pairs of sides are same. Okay, in two triangles, ratio of all the corresponding pairs of sides are same. Pairs of sides are same or equal. For example, if here I have a triangle called, let's say 6, 11 and 13, the triangle ABC, and then I have a triangle here like PQR. In this triangle the sides are 3, 5.5 and 6.5. So I can say that these two triangles are similar. I can write triangle ABC is similar to triangle PQR, right, by SSS similarity. Why? Because see, the ratio is same, na? 6 upon 3 is 2, okay? 11 upon 5.5 is also 2, and 13 upon 6.5 is also 2, right? So all these corresponding pairs of ratio are same, right? AB upon, it's like AB upon PQ is equal to BC upon QR is equal to AC upon PR. It's all are same, right? That's why it is similar. Yeah, okay. So second one is AA similarity. Fine. Now what is AA similarity? AA similarity is when two angles are equal. When two angles are equal, right? So two angles of, obviously when comparing two triangles, right? So when comparing in two triangles, both the angles are equal. That is AA similarity. Okay. Now let's take an example. I'm drawing a triangle ABC. Okay. Triangle ABC. And let's say I'm drawing a line here that is DE, and DE is parallel to BC. Okay, DE is parallel to BC, right? So I can write here that there are two triangles, triangle ADE and triangle ABC. Now I can write triangle ADE is similar to triangle ABC. Why it is similar? Because of AA similarity, right? It is sign of similarity. Why it is similar? Because of AA similarity. See here, this angle and this angle will be equal. This angle and this angle will be equal, right? Because there are corresponding angles. Fine. What are corresponding angles? You remember? We discussed in geometry basic video. This is in corresponding. There are two parallel lines. When there are two parallel lines, the transversal, this angle and this angle are equal. This is called corresponding angle, right? And this angle and this angle are equal. They are called alternate angles. They are called alternate angles, right? Theta and theta. These are alternate angles here, corresponding angles. Fine. So two angles are equal. So I can say it is similar by AA similarity. Right? Okay. Now let's discuss this case here. What happens when these two triangles are similar, right? So when two triangles are similar, that basically means that, okay, I can write this statement here. When two triangles are similar, it means that their ratio of corresponding sides is equal, corresponding sides are equal, the ratio of corresponding sides are equal, and ratio of corresponding sides is equal to ratio of heights is equal to ratio of medians is equal to ratio of inradius is equal to ratio of circumradius, right? Very important point. When two triangles are similar, their ratio of corresponding sides are equal, and the ratio of, I should write 2 points here, right? When two triangles are similar, first point, okay, ratio of corresponding sides are equal, and ratio of corresponding sides is equal to ratio of heights of two triangle is equal to ratio of medians of two triangles is equal to ratio of inradius is equal to ratio of circumradius, right? All these will be equal when two triangles are similar. Fine. Okay. Now see, second point in this the second point will come. Let me write here. Second point. So when two triangles are similar, this is the first point, and second point is the ratio of area of two triangles is square of the ratio of corresponding sides and then heights, right? Because corresponding sides equal to ratio of heights and all, so all this will be equal, right? Now you can easily see why the second point occurs, right? I explain you why the second point occurs. It is because area is equal to half into base into height, right? So now once you take the area of two triangles, right? So those area of two similar triangles, so half into base into height, right? Let's say b1 h1, let it be b2 h2. Half gets cancelled. So b1 h1 upon b2 h2, right? So each term will be what? Now this is base, right? What is base here? Base is any side of the triangle. So once you take the side ratio, so side into side, right? b1 upon b2 into h1 by h2. So this side ratio, it becomes what? It will become square, right? Something side ratio are equal, right? Side, when two triangles similar, this is equal, right? Ratio of base and ratio of height. See here, ratio of corresponding sides will be equal to ratio of heights, right? So when two triangles are similar, the base ratio and height ratio, what is base? One of the sides only, right? One of the sides. So base ratio and height ratio are equal, right? It will become what? It will become square. It will become square, right? That's why it will become a square. Base, this are equal, so multiplication is there, right? It will become a square, right? So that's why if the ratio is what? In area, ratio of area of two triangles is what? A square of the ratio of the corresponding sides. Why is square? Because base ratio and height ratio both are equal in two similar triangles, so it will become a square in multiplication, right? So very important point about similarity. Okay, we'll do questions, right? First we'll do third one, then we'll do questions, right? Third one is by SAS similarity. SAS similarity. Now what is SAS similarity? So SAS similarity is basically when ratio of two sides and the included angle are equal, right? It has to be an included angle, obviously, right? See, when you're making this two, make it two triangles here. Make it triangle ABC and make it triangle PQR. Suppose this is 10, this is 8, this is 5, this is 4, right? So I can see this ratio is equal, right? I can see this AB upon PQ is equal to BC upon QR right? So when AB by PQ equal to BC by QR, so in that case, this is what? This is ratio of sides. So S and S are done. S and S is done, right? Ratio of two sides, first and second, are equal. Now included angle has to be equal, right? That means if this is 30 degree, so this also has to be 30 degree, right? Only included angle, whichever two sides you are taking, 10 and 8 and 5 and 4, so angle between them. So this is the meaning of included angle, right? It has to be equal. If this is equal, then I can write it, okay, triangle ABC is similar to triangle PQR by SAS similarity. Okay, so this is the third similarity, right? This is the third similarity. Yeah, okay, fine. Now, see, we'll discuss few good questions of similarity, right? It's a very important topic, similarity, okay? And we'll be doing lots of questions in similarity. See, how to write the ratio of sides and all in similarity, right? So this will make you clear. This will make you clear. See, if I'm taking here that diagram again, I'm making, right? This triangle ABC and this BC is parallel to DE. So by now we know that triangle ABC is similar to triangle ADE. Why similar? Because it is by similar. Why is it similar? Because it is by AA similarity, right? It is by AA similarity. So AA similarity means this angle and this angle are equal corresponding angle. This angle and this angle are equal, right? Corresponding angle. This is theta. This is theta. This is phi. This is phi. Okay, and this angle A is the common angle, right? Angle A is the common angle. So how to write a ratio of sides now, right? See, diagram, sometimes diagram will be easy, sometimes diagram will be difficult, right? Here you can directly say, okay, DE upon BC or AD upon AB, but in tougher diagrams, like in next one, you can't simply write, right? So in this case, I'll just suggest you to follow the angle wise, right? You pick any angle. Suppose you pick the common angle first. So in common here, in triangle ADE, common angle opposite is DE. And in triangle ABC, common angle opposite is BC. So my first ratio is what? DE upon BC. This is my first ratio, right? Just pick common angle. So here common angle opposite DE, here common angle opposite BC, right? Now you choose this, right? That which triangle to take in numerator and which triangle to take in denominator, right? Suppose in this case I have taken triangle ADE in numerator. So I have taken triangle ADE in numerator. So I'll take it throughout, and triangle ABC in denominator. So I'll take it throughout, right? I'll not reverse in between, right? So common angle opposite DE, common angle opposite BC in triangle ADE and ABC respectively, right? Now again, in numerator, I'm writing triangle ADE. Now come to triangle ADE. In triangle ADE, you pick theta, right? Suppose next angle you pick is theta in both the triangle. So in triangle ADE, since we are writing it in numerator, in triangle ADE, theta opposite is AD. Okay? And in triangle ABC, theta opposite is what? AB. So AD upon AB. Right? Now we'll pick the angle phi. Phi will pick, right? So again, in triangle ADE, since we are writing in numerator, so in triangle ADE, phi opposite is AE, and in triangle ABC, what is phi opposite? AC. So I'll write AE upon AC. Fine. Not only this, right? You remember ratio of corresponding sides is equal to ratio of heights also, right? So if I can draw a height here, you can draw a height here. So let the height of this triangle is AF and height of this triangle is AG, right? So this will also be equal to AF upon AG. AF upon AG, right? So this is how you write for similarity in similarity of triangles, right? Now if I have to take the ratio of also in account, right? So what I wanted was, okay, the second point I'm talking about. What is the second point here? Second point was, if I have to take, okay, what is the ratio of area of triangle ADE upon area of triangle ABC? What is their ratio? ADE upon ABC, right? Now what is ADE here? So in area of triangle ADE, so when two triangles are similar, second point, right, last to last slide. When two triangles are similar, the ratio of area is equal to what? A square of the ratio of corresponding sides and height and all, right? Because I told you what is area. Area is nothing but base into height. So A1 is equal to half B1 H1. A2 is equal to half B2 H2 for second triangle, right? B2 H2 for second triangle. When you take the ratio here, this half will get cancelled, right? Now B1 by B2. Now this is what? This is B1 by B2. So A1 by A2 is equal to B1 by B2 into H1 by H2. Right? So since this both are equal, so what is the area? Area will become ratio of sides square, right? Because both are equal, na? Because when sides triangles are similar, both the ratios are equal. AE by AC is equal to AF by AG. So what is this? Ratio of base. What is ratio of base here? Ratio of base here is what? DE upon BC. See? DE upon BC is equal to AF upon AG. So these two are equal. Okay, these two are equal. So what will happen when these two are equal? So both will be multiplied. So it will become a square, right? So that's why area of triangle ADE to area of triangle ABC. What is the ratio? It is square now. DE upon BC is square is equal to here AD upon AB is square is equal to AE upon AC is square, and then moreover the ratio of heights and all will go on, right? So a ratio of area of two triangles is square of the ratio of the corresponding sides and height and all, right? So very important point this one. Okay, now move to next slide. See, lots of questions are based in this, right? I'll just discuss a point here. What if in case of right angle triangle? There's a right angle triangle, right? So see, we'll discuss separately actually right angle triangle similarity, but just to make you understand how to solve, how to write in case of right angle triangle, how to write the ratio, because it is quite confusing, right? So let's say triangle ABC. There's a right angle triangle ABC. Now BD is a perpendicular. BD is a perpendicular. BD is a perpendicular to side AC. So now here we have three pairs of sides, right? Here we have three pairs of sides. Now let's say here, can I write triangle AB? Sorry, here we have three pairs of triangles here, not sides, sorry. Triangle ABD. So here we have triangle ABD. Can I say triangle ABD is similar to triangle BDC? Can I say it? Two smaller triangle, right? Triangle ABD is similar to triangle BDC. Now I can't say it now because I need at least AA to prove it, right? But here only AA means what? Two angles has to be equal, right? But in comparing these two triangles, only one angle seems to be equal. That is, this is 90 in this triangle, this is 90 in this triangle, now nothing else. Okay, so I need one more angle, right? So that you can easily do. Just one angle theta you need to assume. You need to assume any one angle as theta, right? What will happen now? This is 90, this is theta. This becomes 90 minus theta. Why? Because sum has to be 180 degree. So this is theta, this is 90. So what is this angle? 180 minus 90 plus theta. So it becomes 90 minus theta, right? So one angle is 90, one angle is theta. Third will be 90 minus theta to make this sum to be 180 degree. Okay. Now here again it is 90. This whole is 90, right? This whole is 90 and this is 90 minus theta. So again this has to be theta. Okay. This is theta, this is theta, this is 90. So this becomes what again? 90 minus theta, right? So just you assume one angle as theta and you can now solve everything, right? So you can see that now these two triangles are similar by AA similarity because all these three angles. But see, AA similarity means what? If two angles are equal, obviously third one has to be equal because it is what? It is sum has to be 180 degree. Okay. So here also all three angles are equal. That means what? That means triangles are similar. So ABD is similar to triangle BDC. Correct. So if I write the ratio here, right? Write the ratio here. How to write the ratio? Now we can write the ratio here quickly. Again by picking angle, right? Again we'll decide which triangle to keep in numerator. So let's say triangle ABD to keep in numerator and triangle BDC to keep in denominator. Right? Okay. So now we can solve. Now in numerator triangle ABD, pick any angle. Suppose you pick theta at first. So here theta opposite is AD. Here theta opposite is AD. And here theta opposite is what? BD. So I can write the ratio as AD upon BD. Okay. Next one, you can pick next angle is 90, suppose, right? So here in triangle ABD, 90 opposite is AB. And in triangle BDC, 90 opposite is BC. So AB upon BC. Right. This is how you write the ratio in every question based on the angles, right? When you prove by AA similarity, you must have marked the angles, right? So use that marked angles for writing the ratio, right? No other method. Simply do that, directly do it, right? Third one, let's say third one I pick as 90 minus theta. So here 90 minus theta opposite is BD. Here 90 minus theta opposite is what? DC. So my ratio is what? BD upon DC. Fine. So I can combine these two and form a result, right? A result we can discuss later also. So I can simply write here BD square is equal to AD into DC. Right. So like this you can have any kind of any pair of triangle you can take, right? This is the first pair I have taken. Now second pair is also similar, right? That means I have taken in first one I have taken two smaller triangle, this one, right? Now second one I can also take bigger triangle. Triangle ABC is also similar to triangle BDC. Again by this is equation 2 I can write A similarity. And again I can write the ratio, right? Same way. Because for both these triangles, bigger and smaller triangles, all the angles are what? Equal, right? Now again third one also I can write the bigger one, triangle ABC is similar to smaller one again, triangle ADB. Triangle ADB. Right, so this is a very important case of right angle triangle inside a right angle triangle. Right, we'll again discuss it later. Right, we'll come back to it. Okay, so to find all the values, right? So these three are very important of similarity, because when you write a right angle triangle in a right angle triangle, all the three pairs of triangles are similar. It is two smaller one bigger one and one lower smaller one bigger one and one upper smaller one. Right, all three pairs are similar. Right. And so by similarity you can remember result also here, right? And remember result here. Again we'll come back to it, but it's okay. More you'll revise it, more you will learn quickly, right? You have to find sides in triangle, right? Now let's say this is A, this is B, and this whole is C. This whole is C. So it's a result of similarity. Actually I'm writing here, it's a result of similarity. This whole is C, right? The result is actually if this is A, this is B, this side, this side, this is smaller one, I could write A, B, C and D. So this AD is nothing but A square by C. This CD is nothing but B square by C, and this BD is nothing but AB by C. Okay, you'll remember this result. As a result of similarity only, again all these three sides, three pair of triangles will put similar, and you'll get this result. Very important result, right? And directly write this is A, this is B, this is C. This is very easy to remember also. This is A square by C. This is right AD. I'm talking about AD. AD is A square by C. BD is CD is B square by C. So you write here A, you write here B, you write here C. Upper one is AD is A square by C. Lower one BD. BD is B square by C, and sorry, not BD, CD. CD is B square by C, and this BD is what? This BD is AB by C. Right. So very quickly you can get this value. For example, we have questions also like this, right? Suppose there's a triangle here, and triangle is sides are 6, 8 and 10. ABC 6, 8 and 10, and this BD is the again height of the triangle, right? So what is the value of AD, what is the value of DC, what is the value of BD, right? So in one go you can write, right? What is AD here? What is AD here? AD is basically A square by C. What is A square? 6 square. So AD is nothing but 6 square by 10, that is 3.6. This is AD, so AD is 3.6, right? What is CD here? CD is B square by C. What is B square by C? This is B, right? So 8 square by 10, that is 6.4. This is BD. Sorry, this is CD here. CD. What is BD here? BD is AB by C. What is AB by C? 6 into 8 by 10. That is 4.8. Therefore, I can write BD is what? BD is 4.8. Right. So not at all time taking. Simply you write this value, you get this answer anytime. Okay. It's a very good concept. Remember it. Okay. By similarity. And again, we'll come back to similarity in right angle triangle again. Okay. So for now, what I can write here is, okay. Let's do a question here now. Let's do a question here. Now the question is, there is a square inside a triangle. Okay, let me draw a triangle here. There is a square inside a triangle like this. Okay, there is a square inside a triangle. Okay, and sides of a triangle are basically 20, 34 and 42. This is 42, this is 20 and this is 34, right? This whole side, A, B, C. Fine. So find D. The question is find the length of side of a square. Side of a square, right? Again, a super question which can be solved by similarity in a very easy way, right? Just try and understand this, right? It's a super application of similarity. See, now when you have a figure like this here, so I know that now get all the hidden facts out of the figure, right? Get all the hidden facts out of the figure. Now since it is a square, so square means what? Opposite sides are parallel. So this is parallel to this, obviously. Now name it DE. We can name it DE here. So now DE is parallel to BC. So again same thing. This will be corresponding angle and this will also be corresponding angle. That means I can write that triangle ADE is similar to triangle ABC. Okay. So it is similar. So I can again write the ratio. Okay, write the ratio. How to write the ratio here? So now angle A is the common angle, third angle, right? So you see, if you pick, you mark this as theta, you mark this theta, theta, you mark this as phi and phi, right? So you see here, I want the side of a square, right? Where is side of a square? So let this side of a square be A. Let this side of a square by A. So all four sides will be equal because square means all four sides equal, right? So I want A, so I should pick which angle? I should not pick theta here because theta opposite here is AD and AD is not known and neither I'm interested also, right? Phi opposite here is AE. Again, AE is not known, right? What I'm interested in is I need to find the side of a square, right? So I should pick what? I should pick angle A here. Here, so that is a common angle in both the triangle, right? So here the common angle opposite is A in smaller triangle. In bigger triangle, common angle opposite is what? 42. So I should write A upon 42. Okay, should write A upon 42. Okay, no issue. It's absolutely fine here, right? A upon 42. Now equal to, I need to find the value of A, right? Now equal to what? Equal to what, right? Now this is equal to what, right? So this is again I need for other angle, right? So again I told you, if I picked common angle opposite is fine, but again if I pick phi opposite A is not known. So already A is one unknown variable, another one unknown AE will come. Or if I pick theta, another unknown AD will come. So that means I can't pick. So ratio from ratio of corresponding sides, right? So remember the statement, when two triangles are similar, ratio of corresponding sides is equal to ratio of height. And I told you earlier, when all three sides of a triangle are given, I can get the value of height, right? How? By equating area. By equating area, right? So same thing I should do here also. Okay, let me rub this part. So basically I should write to the ratio of heights. I should write to the ratio of heights, right? Now how to write ratio of height here? So ratio of height can be written, let me draw a height here. You can draw a height, right? This is height for both the triangles, fine. AF and AG. Okay. How you get the height of triangle? See, height of triangle you can get by two methods. First one is by area. Okay. First one is by area. Okay. See. So what is the area of triangle? Root under S into S minus A into S minus B into S minus C. S minus B into S minus C. Where S is semi-perimeter, right? So what is area here? So area is, what is S here? S is 20 plus 34, 54 plus 42, 96. So S is 96 by 2. What is 96 by 2? 48. So 96 by 2 is 48. So S is 48 here. Correct? S is 48 here. Okay, now 48 into S minus A. 48 into S minus A, right? What is S minus A? 48 minus 42 is 6. Now S minus B. 48 minus 34 is 14. S minus C. 48 minus 20 is what? 28. Now what is the area? So area will get by, now see, you have got two multiples of 7 here, right? That means we have got, see, what I can do here, I can split this 6 as 2 into 3. So this 2 with 14 will become 28. So out of 228, 128 will come out, right? Out of 228, 128 will come out. Okay, what is left here now? So 3 is left. So 3 into 48 is what? 144. 3 into 48 is 144. And what is square root of 144? 12. So area is what? Area is 28 into 12. That is 280 plus 56. That is 336. This is the area of triangle. Okay. And this I should equate with area of triangle is equal to half into height into base. Right. What is area? 336. What is height here? You need to calculate. What is base here? 42. Height and base here 42. Right. So we'll get the value. Obviously, we'll get the value here. Simply cancel 8 times. Right. So height you will get it as 16. Height you will get it as 16. Right. So by this you can get height as 16. Okay. Now this is the first method to get the height. Right. Obviously you should know the concept. Right. Now there is a shortcut also, and a super shortcut. Right. If you start using Pythagorean triplet now, you will find geometry really easy. Right. Because 30 to 40% of question you will enjoy solving because of Pythagorean triplet. Right. So in second method I'll use Pythagorean triplet. Right. Remember that I got height as 16. Okay. I got height as 16. Fine. Height as 16 I got. Okay. Now by use of second method, by use of Pythagorean triplet. Okay. So how to use Pythagorean triplet here? See, method 2 by Pythagorean triplet. See, there is a triangle here. Triangle is 20, 34 and 42. I am calculating height of the triangle, right? Now, you just get a triplet. We just get a triplet with hypotenuse 34, right? So just cross check all the triplet, right? Because 34 can be in any triplet also, or it can be derived, right? It can be multiple of any triplet. So 30, as soon as I say 34, it strikes that it is a double of 17. And double of 17 means what? The triplet is what? Triplet is what? Triplet is 8, 15, 17. Okay. How? Again, 34, right? Look at 34 here. Again, you cross check those 6 basic. I told you to remember those 6 basic triplet, right? 3, 4, 5, 5, 12, 13, 7, 24, 25, and 8, 15, 17, 9, 40, 41, right? So all those you cross check here and you see that 34 is what? 34 is a hypotenuse. It is a multiple of what? 17. Look at all the hypotenuse here, right? 3, 4, 5. 5 is the hypotenuse. 34 is not a multiple of 5. 5, 12, 13. Again, 13 is the hypotenuse. 34 is not a multiple of 13. Now similarly, 7, 24, 25. 25 is the hypotenuse. 34 is not a multiple of 25. Then 8, 15, 17. Right. Now 34 is the multiple of 17. 2 times, right? So if the triplet is 8, 15, 17 and it is double of it. It is double of it, right? So I should write, okay, double is what? 8, 15, 17. It is 34. What is double of it? Double is 16, 30 and 34. Double is 16, 30 and 34, right? Now I can't write this side as 30. Why? Because in a triangle, this is a triangle, right? In a triangle, hypotenuse is the longest side. Okay. And 20 is the hypotenuse. It is the longest side, right? So this side can't be 30. So 16 and 30. So it should be what? 30 should be this one and it should be 16. Okay. So this is the funda behind it, right? Okay. I'll again make it with bit of complications in this diagram here, right? Let me make it again. Okay. Just concentrate. A very good concept here to save your time. 20, 34, 42. This is the height. So it should be what? It should be 8, 15, 17 double. I told you that is 16, 30 and 34. Now, not always true, right? So we know that this side also it should satisfy because this is also right angle triangle. So it should satisfy because we have made a bit of guesswork, right? So just check, cross check, it is satisfying or not. It is satisfying. See, this is 42, this is 30. So it should be 12, right? This is a right angle triangle, this side also right angle triangle. So 12, 16, 20, another triplet, right? Derived from 3, 4, 5. 3, 4, 5 into 5 times. Okay, sorry, 3, 4, 5 into 4 times. 12, 16, 20. So that's satisfying, right? This is satisfying. So what is the height? So height is 16. So height we got as 16, right? Just try. See, you can always do by this method. This is a concept, right? But try this kind of logic, right? If you try this kind of logic, and you can beat the question within minutes, right? These things are very important, very important, right? So try using these things. Okay, triplets in case of right angle triangle is a super concept, right? You should always try by putting triplet, try to recognize a triplet, right? You can save a lot of time there. Okay, so anyway, I got height as 16, right? I got height as 16. Okay, now come back to this question. Rubbing all this, right? Now height is 16. Okay, so that means what basically now? The ratio of sides of two triangle, right? So common angle opposite is A, common angle opposite is 21, right? Common angle opposite is A, common angle opposite is nothing but 21. Okay, this is the height of triangle. Na? So 21, right? Now, so ratio of sides of triangle is equal to ratio of height. It was ratio of height here. So you see, this is A, right? This is A. That means it's a straight line. This square is 90 degree. This also 90 degree. It's a straight line. So this also should be A. This also should be A. So this is A. Whole is 16. So height of a smaller triangle is how much? 16 minus A. Right? 16. This length is A. This length is A. This FG is A. Right? FG is A. Why? Because parallel to the side of a square. Okay. So A. So whole is 16. So height of a smaller triangle is 16 minus A upon height of bigger triangle, that is 16. Right. So this is the ratio we got here. It's a super question. I can get the value of A from here. 16A is equal to 42 into 16, right? 420 plus 252, that is 672. 672 minus 42A. 42A, right? That means 58A is equal to 672. Therefore, A is equal to 672 by 58. Okay, that is 336 by 29. So answer is what? 336 by 29. This is the answer for this question. What is the value of A? 336 by 29. Okay, so very nice question. Lots of concepts we covered in this video, right? Especially this question. Understand this question, you can apply in many other questions, right? This concept. Okay, thank you. We'll continue next video.